Hey guys, in this lesson I want to go ahead and talk about partial fraction decomposition again, and I want to do another example about repeated linear factors before we get into another bit more difficult with quadratic factors. Okay, so we talked about last time saying that when you have a repeated linear factor, you're going to have to account for that. So right here, if you notice, okay, well, first of all, the degree in the numerator and the denominator are the same. So that's when we know we can continue and start factoring the denominator. A lot of times you notice if the degree on the numerator is bigger, then we can use long division to simplify it out a little bit. But for this one right now, we notice that you see how it's an x squared. So what you guys have to do, you're going to put a for the constant, and you're going to have to put a over x, okay, plus, and then you're going to do another one to use x squared. Okay, and let's say this was x cubed, then you would do x squared, and x cubed. Okay, same thing here. If this was, let's say, x plus 3 to the second power, then you would have to do x plus 3, and then you have to do x plus 3 to the second power, because they have their linear factors that are doubled. And what you would have to do is incorporate that into this one here. Okay, this one only has 1, so we're just going to do c times x plus 3. Now, to give you a better explanation, you can go ahead and look at the previous video, and I go over an example there. But for us now, for sake of time, we're going to go ahead and set it up. But remember, so this is a linear factor, okay? So we have to do x and x squared. And then x plus 3, that's just 1, so it's just x plus 3. Okay, so now what I have to do is I have to go ahead and clean it up, solve this guy. So what I'm going to do is I'm going to multiply by the common denominator, which is x squared times x plus 3. And you notice when that happens, this guy simplifies out. I'm just left with a trinomial up here on the top. Okay, so we're left with 6x squared plus 15x plus 9. Okay, so now, same thing, distribute it. One of the x's is going to cancel out, so you're going to be left with x times x plus 3 plus, and then continue, the x squared simplifies out. You're left with just b times x plus 3. And the last one, the x plus 3 simplifies out. You're left with c times x squared. Okay. All right. So now we're going to go ahead and continue. These are all linear factors, so this is nice. We're going to go ahead and okay, we want to, remember we have a, b, and c. I can't solve all three at the same time. So what I want to do is I want to eliminate one of them so I can solve for the other. And actually eliminate one of a and b so I can simply solve for the other ones. And if you notice here, I'm going to let x equal to -3. Okay. It doesn't matter. I can start off with 0, but let's say -3. Let x equal -3 here. Okay, so I'm going to plug in -3 into everything. So we're going to have 6 times -3 squared plus 15 times -3 plus 9. A times -3. -3 plus 3, all right, plus b times -3 plus 3, and then plus c times -3 squared. All right, so now let's go ahead and do some mental math. -3 squared is 9 times 6 is 54. 54 plus 9 is 63. 63 minus 45. Let's just do that for right now. Okay. And so I just did plus this one. Okay, I got 63 minus 45. Over here, -3 plus 3 is 0. And this becomes a 0. This becomes a 0. This is left with 9c. 63 minus 45. What is that? 13. That would be 8. 18. Okay. Equals 9c. So now c is equal to 2. Nice. Okay. All right. Now that I have c, let's go ahead and do the other ones. We let x equal -3. So what I'm going to do now, I'm going to let x equal to 0. So this guy's going to cancel out, and then this guy's going to cancel out, so I can solve for b. So I'm going to go ahead and do it here. And let's see, 6 and then 0 squared. And let me just write it out here. Let x equal to 0. And then plus 15 times 0 plus 9. And then a times 0, 0 plus 3, plus b times 0 plus 3, and then plus c times 0 squared. All right, and I love 0, makes life a lot easier. That becomes 0, that becomes a 9. Over here we get 0 times anything is 0. 0 plus 3 is 3, so that's 3b. And then 0 squared it, well, that's just 0. So you end up with b is equal to 3. Nice. So I got c equals 2, I got b equals 3. So now I just got to figure out my a value. So what I'm going to do now for my a value, I'm going to, because I got a, I got b, all I got to do is pick any value for x and then plug in my c and my b as well. So I'm just going to pick an easy value, let x equal to 1, and at the same time I'm going to plug in b and c. Okay, so let's see, 6 times 1, and that's squared, plus 15 times 1, plus 9. And then a, I don't know yet. X is 1. 1 plus 3 plus b is 3. And then 1 plus 3 plus c, what did I get for c? C is 2, and then 1 squared. All right, guys? All right, so now let's go ahead and solve this. So see, 1 squared is 1 times 6 is 6. 6 plus 15 is 21 plus 9 is 30. All right. 3 plus 1 is 4. 4 times 1a is 4a. And then 3 plus 1 is 4. 4 times 3 is 12. Okay, and then this is 1 squared. Be careful, it's 1. 1 times 2 is 2. Okay, and that gives you 14. So, and then 14, take it across. 30 minus 14 is 16. So you get 4a equals 16. A is equal to 4. Great. So this is just basic algebra. I'm pretty sure if you're at this level, you know how to do all that mentally. So what are my values now? So a is 4. Now be careful, it goes in order, okay? A goes with my x plus b goes with my x squared. So b is 3. 3 over x squared. And then my c is 2. It goes over the x plus 3. And there it is, guys. There's your partial fraction decomposition. All right. So now let me go ahead and give you some examples with distinct linear and quadratic factors. Okay. So I went ahead and kind of just did it ahead just to kind of explain it to you. Somebody asked me for this problem. All right. A very good problem. Now, if you notice this guy, okay, that's a linear. Now, this guy here, I can't factor it anymore, so I'm just going to leave it. But notice it's a quadratic. So remember, the degree on the top has to be 1 less than the one on the denominator. So if this is a quadratic, this has to be a linear factor. This is a linear, so this has to be a constant. So now we start off the same way. We're going to go ahead and simplify it out by multiplying everything by the common denominator. So what you see, this cancels out. Okay, right here, one of the x's cancel out. You're left with x squared plus 1. And then over here, the x squared plus 1 cancels, and you're left with just the x times the bx plus c. Well, what you go ahead and do now is you're going to go ahead and distribute. Now, this is a little bit different than doing the linear factors. So you distribute the ax squared plus a, and then this becomes bx squared plus cx. Now, you have to go ahead and make a system. Yeah, I know, a system of equations. So what happens here, check it out. Ax squared and bx squared. I'm going to go rearrange it, so I'm going to put them together. And then here, I'm going to factor. I factored out a plus b. Okay. And if you notice, okay, and then I put everything else here on the side. Now, what this is telling you that the left side is equal to the right side. Well, in order for that to happen, that means the x squares have to equal the coefficient of the x squared on the left. So if I factor this out, that means the coefficient of the x squared has to equal a plus b in order for it to be equal. And that makes sense. And knowing that, I can go ahead and create my system. So a plus b is here equals, well, the coefficient is 1. Okay. And then we do that the same with the other terms. So the x, cx, goes with the x on the left side. Well, wait a minute, there's no x. Correct. So the c has to equal 0 because there's no x. And then the a is your constant, which is by itself. And if you notice, a would actually equal -1. And actually, this one comes out to be pretty simple. So now you have your system here, all right? Excuse me. Now we know that A is equal to -1, plug it in here, and I can solve B equals 2. So now, notice how we come up here. Okay, there's your A, your B, and your C. So A we know is -1, B is 2, and C is 0. So here we have, this is our decomposition.